All right, so in the last video, we had a short conversation about what NumPy is and why we use NumPy. Basically, it's sort of the premise that a vanilla list in Python is a very inefficient construct. It's immutable, it's difficult to work with, you have to do a lot of hard coding and do a lot of extra coding to be able to do any sort of unique functions that, even though they may be common to data analytics, aren't built into Python innately. Okay, so the creators of NumPy then come along and they talk about, hey, let's create a package that allows sort of a framework to wrap around these lists that enable people to use the list more efficiently, to be able to use the lists a lot easier, that provide a lot of universal functionality, that provide a lot of really cool data analytics, pre-written code that you can just simply start using and sort of hit the ground running in your data analytics. Okay, so obviously, since in this module we're going to be using NumPy, I'm going to need you to create a new NumPy project in PyCharm. Okay, so if you need to pause the video now and go create a new NumPy project, go ahead and do that. All right, so now that we have our new NumPy project created, so kind of have this blank slate here. I called mine NumPy module. You can call it whatever you would like to. Obviously, if we want to write some Python code, we need to go ahead and create a new Python file. So we're going to create a new Python file here. And I'm just going to call this NumPy work. There we go. Okay, so in order to have access to any external package that isn't natively imported into the Python module, you'll need to use the import keyword. Import, and then we're going to import NumPy because the package is called NumPy. Okay, so now obviously as you're looking at this, you can see there's sort of an alert. Something is wrong. Okay, and the thing that is wrong at this point is you don't have the NumPy package installed on your virtual machine or your virtual environment. Okay, so we're going to go ahead and need to import, or we're going to need to install this particular package. Okay, so to do that, we're just going to right click. We're going to go to Show Context Actions, and it actually tells you, hey, what's wrong is you don't have NumPy, so would you like to install that package? And we're going to say, yes, let's go ahead and install that. Now in the lower right corner, you're going to see that it's telling you installing package NumPy. Once it's done, it'll tell you that the package was installed successfully. It's going to reindex the packages in your virtual environment. And now you're ready to go. So let's go ahead and validate this, make sure everything is working. Okay, so we're good coders here. So obviously we want to make a conditionally executed main method. We want to go ahead and define our main method. Oops, if I can get my fingers on the keyboard correctly here. And then we want to go ahead and just sort of run a quick test here and make sure everything is running correctly. And there we go, we have our test, all right? Now, nothing went wrong with the import NumPy, so we're assuming everything is good, but just to verify that everything is fine, we're gonna go over and we're just gonna go ahead and print out the NumPy version number, okay? So to do that, we're just gonna simply go use the print function. We're going to call the NumPy module, and then we're going to use this little hidden function called version. It's actually not, it's a data attribute is what it is. That should spit out which version we're using in NumPy. Okay, so if I run this again, now we can see we are working on NumPy version 2.0.0. Okay, so you should have those exact outputs on your PyCharm project. If not, go back, troubleshoot, see if you could figure out what you did wrong and see if there was any sort of missteps that you did there. Okay, so now we have NumPy installed, we have NumPy imported, and we're ready to start sort of doing some of this NumPy work. So before we do that, though, we want to back up just a little bit and have a little bit more of a conversation about this idea of an array. In the previous video, I talked to you about how an array was nothing more than a list. A list. Okay, when we talk about a list, I always like to use like a grocery list. Okay, grocery lists are something that we all know. I start with this and that and sort of move forward, right? I get bread, I get milk, I get lettuce, I get whatever, okay? And a list just has a single column of values, right? Bread, milk, lettuce, whatever, mustard, ketchup. Okay, that's what we would call a single dimensional or a one-dimensional list. Now, if we sort of go to this idea that an array is a list and a list is an array, then I can say a grocery list, because it only has one column, is what we call a one-dimensional array. Okay? So when we're dealing with data analysis, a lot of times we want to collect other data points that correspond with those initial values. Okay? So let's say we have a grocery list, but now we want to keep track of sale prices. So what I can do is I can actually add another column to my grocery list that says, here is the price. Okay, so now I have bread, milk, lettuce, but then to the right of bread, I now have bread being, however many dollars, milk being however many dollars, and lettuce being however many dollars. Okay, so to sort of visualize this, we're going to jump over here to an Excel spreadsheet. Okay, I always use an Excel spreadsheet because a lot of people have used Excel. It's sort of a very, very, very common tool that is used. Microsoft's made it very, 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 very popular. So what we're looking at here is what we in computer science would call a two-dimensional array or a multi-dimensional array. Okay, so anytime you hear multidimensionality, anytime you hear two-dimensional array, anytime you hear anything like that, just envision an Excel spreadsheet for now. Okay, so what we have here, and when you go into later classes, we're going to talk about the fundamental realities. In Cyber 150, we talk about the fundamental realities of just what a two-dimensional array is. But for now, for 101, just think of a two-dimensional array like an Excel spreadsheet. Okay, so if we think of a single-dimensional array, what we would do is we would highlight something like this. Okay, so I can have bread, I can have milk, I can have lettuce, I can have mustard, I can have ketchup, okay? And we know that even though these are offset by 1 because we always start at 0, I can go to A1 and get this value. I can go to A2 and get this value, okay? So in this case, A would be sort of the name of the list, and these numbers would be our indexes. Okay, so if I had grocery list, if I created a list called grocery list, I could dereference it. Now again, just to alleviate confusion, Excel starts at 1. We in computer science start at 0. Okay, but just for the sake of illustration, we're using Excel. I can go, hey, go to list A and give me 1. Go to list A and give me value 11. Go to list A and give me value 17. Okay, so that's what we call a one-dimensional list. Now, as I mentioned earlier, what happens if we want to add another column of information? Okay, now I have the situation where I have multiple columns and I need to figure out how to reference these things. Okay, so this is what we would call a two-dimensional array. Okay, so we would call this grocery list, and grocery list would be comprised of AB, columns AB, or arrays A, B, okay, because this is an array and this is an array, okay? And then I would go through and I would say, in grocery list, give me column A, number 1, okay? So you see how we're sort of adding depth and adding depth and adding depth, okay? In general, when we're doing data analysis, at the very least, we are going to be doing two-dimensional data presentation or data organization, okay? We may have A being a dependent variable and B, C, D, E, F, all the way through L being independent variables. And each of these has numerical values that we want to understand the relationship between, okay? So Numpy allows us to create in Python essentially these Microsoft Excel spreadsheets, okay? And that's kind of what we're going to talk about moving into the next video on how we do that kind of stuff, okay? All right, so we're going to take a quick break. We're going to come back on the other side and talk about some of the Numpy fundamentals.